In 2022, F1 rips up the rule book and we will see the new generation of an F1 car, which is a ground effect car. The last time we saw those on an F1 car was the early mid-1980s.
Well, what we're trying to do, I think, is unearth what's been one of the best kept secrets in motorsport.
With a reputation as F1's innovators, Team Lotus debuted the first ground effect aerodynamics at the opening round of the 1977 season in Argentina, having been the pioneers of aerodynamics with their winged cars a decade earlier. The Lotus 78 had side pod skirts, bodywork extensions which dropped to the track surface from the car's edges. When lowered, the lower air pressure created underneath the car gave them huge amounts of downforce without the drag that comes with wings. But it was discovered rather than designed. When the team attached card to keep an experimental side pod design in place in the wind tunnel, the unexpected amounts of downforce pitched their developments down a completely new path. The other teams quickly took notice and the skirts were widely copied, beginning the ground effect era.
40 years on, we're going to go back to ground effect. So I thought, what a wonderful opportunity to be able to document the ground effect car, provide all the data for that that's never actually been available anyway, and then compare that to the 222 car.
We were introduced last year to Robert Fernley through our Vice-Chancellor, and he obviously made it quite clear he'd got a series of historic cars he'd like to do something with. And then we decided we needed to start doing something as a student study, so we got involved in the aerodynamics project, which was really to reverse engineer the ground effect car to understand how the aerodynamics work.
You know, we started off by looking at how do you improve advanced performance engineering for young people and get them more involved and more excited. And then we linked it with the industry, and these things take time, but the industry is just so behind this now, it's phenomenal.
Motorsport has been very good for me over the years. I come from a very modest background, and I ideally wanted to see if we could get the university to a high profile and also provide the support for the kids.
Here we've got industry and education working absolutely in partnership, so students get full exposure to the industry, which is great for them.
When I came here a year ago to look at these facilities, I was just absolutely astounded as to the quality and the fact that very few people knew about it. And you know, with George being quite a good pal, we looked at how we could help him really promote this as becoming one of the go-to places for motorsport engineering.
And it's grown and grown from that, so here we are now literally getting the car ready to go testing at Anglesey next week with Johnny Herbert, and then to go and race it down at Brands Hatch in August. So all of this has been happening during lockdown. It's been somewhat quite intense, quite crazy. It's been fantastic for the students to get the practical side of this.
So what I'll be driving today is this Ensign 180B, which was raced by Mark Sura, Eliseo Salazar in the 1981 World Formula One Championship. Mark finished 4th in Brazil and 6th in Monaco, Eliseo finishing 6th in Zandvoort. So it's not a bad car. Jim Crawford, he drove it. Bob Fernley ran the car from Force India, and this is the car that we will be driving. And thank you, Bob, for allowing us to happen. It's nice to see my name finally back on an F1 car. But how are we going to sort of see the two generations and the difference between those two? Well, as you can see, with all these sort of stickers that are all over the car from the front wing, they're actually underneath the floor, all the way back through the bodywork, and finally on the rear wing. We've got 250 sensors that will be reading all the aerodynamic data that we can analyse to see the difference between the two generations of an early 1980s car to the new rules for the 2022 Formula One regulation. So it's going to be fascinating to see the difference between the two. Tell us a little bit about the whole project, because obviously it's Bolton University that's a big important part of this journey we're on.
Yeah, and what we're trying to do, John, is give the students the opportunity to understand ground effects. So effectively, originally they were going to come out next year, as you know, they're now delayed to 22. But the last time I ran this car in F1 format was in 1982, so we're 40 years on, which is quite a remarkable achievement really when you think about it. We've resurrected a 40-year-old car to be able to do this test. What it means now is the students can understand the initial conceptual ground effects that were done in the 80s, 70s and 80s, and then we can compare them to what's going to come out in 22. So what it's doing is it's allowing them to get into ahead of the game, if you like, in terms of where Formula One is going, so that when they come to the job market, hopefully they're current.
Yeah, the first impression is just where these wheels are so close to my chest compared to what I'm normally used to. So we sit so far forward in one of these cars. And initially, you always want it to be sort of on your chest, on your shoulders, the rotation of the car. And it sort of initially turns in with understeer, but then it really picks up quite a lot of grip as you pick up the speed and the grip starts to develop, but then it actually goes out of my chest towards the steering wheel, which I don't want, because that means it's then becoming a bit pointy on the front. Early days. The positioning of the car on the exit seems to have more flow to it.
And what about the initial turn-in? Is that any?
It's okay, that hasn't probably changed massively. I just feel that when I do go in on those slower medium, it's probably still too much of the understeer, but it's constant through the corner.
What that's saying to me, from where we are now until we do the final test, is that actually we're not far away from a ride height point of view. Probably I would come up 5 mil at the back if I was sitting here now looking at performance.
Yeah.
Move your centre pressure.
Yeah, move it forward. Sure.
And that should give you
normal.
The connect and
correct
some of the
just correct. Yeah. So what have we been doing today? Well, we're doing a lot of constant speed running, something they still do today. And that really sort of means that when we go down the main straight, there'll be a set speed that I have to stick to all the way down the straight. And then that just gives a much better reading of what is happening underneath the car. So we sort of started with the car sort of quite flat. We then went down a little bit on the rear end, did the same thing once again. And then for the last change, we actually then went up on the back. And what that does, and what I can feel in the car, is sometimes when the air is going underneath the car, it's detaching. So when I'm going through a corner, I can actually start to feel a bit of a sort of a numb patch where it's understeering, but actually then I can't really feel where the back end is, and that's normally where there's a bit of a detachment underneath the floor. So that's something we'll be able to sort of look at. More importantly, that's what we can see the difference between this 1980s car to the 2022 cars. Another interesting test that we did today is one of these, a 1980s brake duct. Well, actually, it's a 2020 brake duct, 3D printed from the 1980s. Now, you've got the rear wing, and obviously you want that to be as clean as you possibly can to get all the air that it can on it to create the downforce. But of course, these are mounted right in front of it. So the amount of air that's been taken away from that wing, we don't really know. A modern day Formula One car, it's all enclosed inside the rim of the wheel. So we took it off, we gave it a run, we've got all these sensors on it, so we should have a good idea of the difference between an 80s brake duct and a 2022 brake duct. But Bob, now we've sort of collected all this data, what's the next step?
Well, the next job for us is that we've done, as you know, we've done 3 ride height sweeps effectively, and we've done 15 laps per sweep in different areas. So we've got enough data now to be able to send all that back to the university. They will then be able to use that as to correlate the CFD work, because the CFD should tie in with what we've done here today.
It's all reverse engineering, and that I feel like is almost as big of a task as creating a car from scratch, because one side will be close to another, but it won't be exactly the same. But it's definitely a task and a challenge, but it's rather exciting to be part of it.
I'm on tyres, bodywork and fuel, so if they need a tyre change, first guy on the line, fuel, then bodywork, so if one of the sensors was to fall off, something like that, I'll put scotch just to refit it, things like that, yeah.
The students working on this project are also involved in other projects. So Em, for example, is also working, or has been working last year and this year with the British touring cars.
I'm Emily Platt and I'm a second year student at the University of Bolton. I'm the front end mechanic, but I've also been working on the scanning side of the vehicle as well beforehand. It's been quite interesting to do, and I've been able to then link that into my university work as well, so it's been able to boost my grades.
Is it interesting to be studying ground effects?
Yeah, it's very interesting to me because it's one of those things that they had an idea of what they were doing and they had a general idea of what made it faster and what made it more effective, but they didn't nearly have as much technology and the tools that we have today. So it's interesting to see the development of what they could have done and small tweaks that could have made it 10 times better, or what would have made it 10 times worse that they either didn't know or had to find out through manual methods. It was interesting.
And this positions the students at the premier part of the industry. You know, students who've had track experience working on aerodynamics like this for F1 cars, they're oven ready, they're ready to go into the industry. And that's what people say they want these days. They don't want people who are theoretical, they want people who are practical, who can go on the track, add value straight away to the team.
Finally, the time has come. It's qualifying day. We had a little bit of practice yesterday, had a few issues with the gear linkage, so I wasn't able to get the gears. But the guys, the crew from Bolton University were working until 1 o'clock last night to get the car prepared. The gearbox feels absolutely perfect now.
If you look at the Anglesey programme, it was almost textbook. Yesterday was challenging. The guys got home at 1 o'clock in the morning. That's what they've got to learn.
Working out a couple issues with gear selection, and therefore wore a few dogs in the gearbox. But all back together now, and Johnny's happy, so I'm happy.
So now it's time for me to get this on, and let's go qualifying. Wish me luck, everyone. Okay at Druids, a little bit of understeer there. Graham Hill understeer still pushing a flat, so I'll have to wait to get on the power. Surtees probably not that bad actually, so I'll probably say that's okay. Good job. Right, Bob, that was better.
Gears?
Was better, yeah. It's a lot further over to the left, so it took a bit of time to adjust. It's too sharp initially. Mid-corner exit, we've still got that same problem. That hasn't gone away.
Mid-corner exit understeer.
Yes, and what it also does, when the tyre gets hot, you get a loose rear end when you brake. That's instability at the... Yeah, that's about it, I suppose.
No, the main thing is we've got the laps in.
Yeah.
That's what we've been able to do.
No, sure. experience. You know, this sort of classic racing is something I've seen from afar, but to be involved with it, and it's just lovely to be involved with a car like this from 1981, ground effect car, but it's, you know, physically very, very hard. No power steering like the modern day drivers have, but great to have the old sort of stick shift back in. I love all this heel in toe and flipping the throttle, getting into gear when it needs to be done. Normally, of course, you've always got a team around you. I have exactly the same thing, but of course it's from the University of Bolton, and those students, who I have to say have done a really good job. The car mechanically hasn't really had any issues whatsoever. The brakes are always very, very hard. And the preparation is very good at the same time. But just the whole crew, really good for them. Why? Because it's a great experience for them to run a race car, but a Formula One car as well. So it's great for the university and great for the guys and girls who are actually on board with this wonderful project.